Hello and welcome to this video tutorial. In this video, we're going to be working on Skills Practice 2.2b, Newton's second law. Please remember to pause or rewind the video as you need to. Read along with me, and please have your calculator and formula sheet ready. Newton's second law states that acceleration of an object is directly related to the force on it and inversely related to the mass. You need more force to stop an object with a lot of mass, or inertia, than you need an object with less mass. The formula for second law can be rearranged the following. Okay, so in other words, what was read to us was force is directly proportional to acceleration. The more force you apply on an object, the more it accelerates. However, it's also indirectly related to the acceleration is indirectly related to the mass. What that means is less mass, smaller masses accelerate more. Okay, bigger masses accelerate less. Okay, now putting those together, and we get acceleration equals F over m, okay, which is usually written multiplying both sides by m as F equals mass times acceleration. So we're going to be working on this throughout this video. Now, how do you know you're looking at acceleration? Well, acceleration is going to have the units meters per second squared. Go ahead and annotate that and make a note of that. When are you looking for mass? When you see the phrase kilograms, the unit of kilograms. And how do you know you're looking at a force? Well, you're going to see the unit of newtons. So make sure you know how the units connect with those variables. Okay, meters per second squared connects to A, kilograms connects to mass, and newtons connects to force. Okay, I'll let you go ahead and look at the example there if you feel you need to, but let's go ahead and jump down to question number 1. Okay, and actually before we begin, I want to take a moment to number off these problem solving boxes here. So there's 1, 2, and 3 on the first page, and then we have 4, 5, and 6 on the second page. So read question number 1 along with me, please. What is the rate of acceleration of a 2,000 kilogram truck if the force of 400 newtons, or 4,200 newtons rather, is used to make it start moving forward? So I read this, 2,000 kilograms. Remember, kilograms goes with mass, so we're going to label that with an M. Okay, then I read this, 4,200 newtons. Newtons goes with force, so I'll label that F. And we're looking for A. A is the question mark. Okay, so 2,000 and 4,200. Scroll down to question number 1. So 2,000, 4,200. That would be the force. That would be the mass. And you guys were looking for acceleration in this problem. Now, your relationship equation that you're always going to be working with is going to be your net force equals ma equation. And we're always going to start with that. But in this problem, you guys are solving for A. Okay, now in order to solve for A, you have to get rid of M. So how do we get rid of M? We're going to divide both sides by M and rewrite the equation. So A is going to be F divided by M. Now plug in your numbers. F was 4,200 newtons. Mass was 2,000 kilograms. Okay, go ahead and take a second to divide those two. And you get 2.1 meters per second squared. Now the unit for acceleration could also be newtons per kilogram. That would be acceptable too. Question number 2. What is the acceleration? Okay, so A is question mark, of a 0.30 kilogram ball, that's mass, hit over the fence with a force of 25 newtons. Okay, so first thing you do is annotate, read and annotate. So 0.3 and 25. 0.3 and 25 newtons. Again, we're looking for A. And again, the original equation is going to be net force equals MA. And again, we're going to go ahead and divide away the mass in order to get A by itself. So A was equal to F over M. F in this case is 25 newtons over M, which is 0.3 kilograms. And 25 divided by 0.3 gives us about 83 meters per second squared. Number 3. How much force, this time F is the question mark, is needed to accelerate 68 kilogram skier, there's the mass, at a rate of 1.2 meters per second squared, there's the acceleration. Okay, you're looking for force. And again, the equation we're working with is net force equals MA. But you guys will notice that if I'm solving for force, force is already isolated. So I can just plug right into that equation. We're going to go 68 times 1.2. 68 times 1.2 is 81.6 or 82. We can round it up to 82 newtons. Okay, number 4. What is the mass? That means mass M is the question mark. Of an object that requires a force F of 30 newtons to accelerate at a rate of 5 meters per second squared. That would be A. So we're going to go, let's see, 30 and 5. $30 newtons, 5 meters per second squared. Just double check on that. Yes, 30 newtons, 5 meters per second squared. So that would be your F. That would be your A, and we're looking for mass in this problem. So net force equals M times A. But if we're looking for mass, you have to isolate for mass, isolate the M. How do we get the M by itself? Divide by A. So now the mass is by itself, and it's going to be force divided by, acceleration. The force was 30 newtons. The acceleration was 5 meters per second squared. And that's pretty easy mental math. That would give you 6 kilograms. Okay, number 5. Again, what is the mass? That's the question mark of an object that needs a 4,500 Newton force to accelerate a rate of 5 meters per second squared. So 4,505 Okay, start with the main equation. You can see we're solving for mass. You're going to have to isolate the mass. We can do that by dividing by A, just like we did in the previous problem. So M is equal to F over A. See, the F is going to be our 4,500 newtons. And the A is going to be 5 meters per second squared. Now we know, ladies and gentlemen, we know that 45 divided by 5, if I just divided those two right there, that would be 9. So my answer is going to be 9 with 2 zeros, or 900 kilograms. Okay, and finally, last question. It says, what is the acceleration? We're looking for A. 6.4 kilogram bowling ball. There's the mass with the applied force of 12 newtons. So 6.4 and 12. 6.4 kilograms, 12 newtons. So 12 newtons is the force, 6.4 kilograms is the mass, and we're looking for acceleration here like we did in the earlier problems. So F, right, is equal to mass times acceleration. But again, you're looking for acceleration. So how would you get the A by itself? We have to divide by mass. And we'll go 12 newtons divided by 6.4 kilograms. And when we divide these two, we get about 1.875, or I can just round this up to 1.9 meters per second squared. Okay, I hope you found this video tutorial helpful.